1.
All right, well, let's think about it.
800.
Well, let's see. What's e to the 0 equal to?
1.
1. So this becomes 800 over 1 plus 49 times 1. So it becomes 800 over 50, and that's just 16. All right? 16 students. All right, now let's think about what's happening here. All right, we start off with 16 students that have the flu, and this is I've been using this problem for a lot of years, but this year with coronavirus, it's probably especially pertinent. So it's growing exponentially, and then let's think about what happens when t gets really, really large. All right, when this gets really, really big, e to the negative 0.2t, right? If I had to sketch y equals e to the negative 0.2t, it's exponential decay. It gets smaller and smaller and smaller and smaller, closer and closer to 0. So what happens is this function, this whole term on the bottom, 49 times a number really, really close to 0 is a number really, really close to 0. So all of this stuff that I'm highlighting here, all this stuff pretty much goes away when t is really large, and I get 800 divided by 1. So this function is going to level off, and this is not an accurate scale here, but this is going to level off and never quite hit 800. So when a logistics function is written in this format, this gives you the maximum amount called the carrying capacity. All right, and because this never quite gets to 0, the whole function never quite gets to 800, but it'll get as 799 point whatever you want. It'll get as close to 800 as you can imagine. All right, and let's just practice solving a couple of these equations. Just because it's a little bit different, it's a little more complicated of an equation to solve than we've been working with. So let's see what that would look like. Let's do part C. The school will close if there are 300 students infected. Will this happen? Yes, it will happen. We can see by the graph we produced, it will hit 300. If so, when will it happen? So let's go ahead and start off this equation. 300 equals 800 over 1 plus 49 e to the negative 0.2t. Excuse me. And I have one of these for you guys to try during the group work if you get to it. Does anybody have any suggestions on how to proceed?
Multiply both sides with 1 plus 49e.
Yep, great idea, Diana. Yep, let's get rid of the fraction. In other words, let's multiply both sides by the denominator. Which is really the same as thinking of this as cross multiplication. If you thought of this as 300 over 1 and cross multiply, we'd end up with the same result here. All right, so now we've got 1 plus 49 e to the negative 0.2t times 300 equals 800. What do you guys think would be easier to do? Distribute the 300 or divide by 300?
Divide by 300.
Okay. They both have their pros and cons. So I was going to do whichever one you guys suggested. But we're going with divide by 300. All right, so here's something I don't want to do. I like your suggestion, but the con is, the downside is this 800 divided by 300 is a repeating decimal, and rounding off now is going to decrease the accuracy of my final answer. So I'm just going to leave it as 8/3. All right, so what do you think now, guys?
We subtract by 1.
Good. Subtract 1. And what's 8/3 minus 1?
5/3.
5/3, right? Because 1 is 3/3. All right. What's next?
We divide by 49.
Good. We divide by 49. And remember that when I divide by 49, when I divide a fraction by 49, the 49 basically joins the denominator. So I'm going to get e to the negative 0.2t equals, I'm going to have 5 on top, 3 times 49. Well, 3 times 50 would be 150. So it's going to be good. 150 minus 3. All right. Now all of a sudden it's a easy problem. Now I can rewrite using ln. ln of
E.
Nope.
5 over 147.
Yeah. So be careful. And if you're tempted to say ln of e, so hold on, Chiruza. Maybe you weren't off the mark. Some teachers teach you to do this. They'll teach you to they'll say ln on both sides. ln of the left side equals ln of the right side, and now we say ln cancels out e. Yeah. If you're comfortable with that, it works. I really prefer to think of it as rewriting, but I've taught it both ways, and I haven't really had a clear-cut winner for, when do students do best. So I'm going with this one here. But yes, you could take the ln of both sides, which the end result is just rewriting it. So the exponent becomes the answer to what is the log equal. The log equals the exponent. I divide by the exponent, and then I put it into my calculator. Natural log of 5 divided by 147, all divided by negative 0.2. And does anybody have an answer on this? I have an answer. Did not take long for this school to get shut down.
$16.904.
Yeah, yeah, yep. Almost just a little under 17 days.
The teacher 6:17.
What's that? Yeah, we could just call it 17 days, yeah. On the 17th day, school is closed. On the 16th day, you're probably still in school. It's a good point. Can anybody visualize this in your head? What would the formula be if I changed the 300 to a 200? Be ln of what?
If you change, like, instead of 300, you put 200.
Yeah.
Oh, it's gonna be just 4.
You would do ln
wouldn't that be 3 to the 140? No.
Yeah, 3 times 1 over 49. Yeah. So
So
in
you would do 4 over 98.
well, Chiruza was noticing this would be a 4, right?
Yeah.
Then I'd have 4 minus 1, which would give me 3. 3 times 1 over 49, wouldn't it just be
49.
3 over 49?
Mm.
Right, and that's what we would get. And that'd be about almost 14 days. All right, I'm gonna scroll up, unless anybody wants me to wait. Anybody want me to wait? All right. When I put you into groups, try this one last. This is really for people that want an extra challenge. But this problem won't be on the test. But do make sure you try the regular log equation, because I am going to put 2 of these on the test. All right, and this is an equation I found someplace for the what's called the limiting magnitude of a telescope. And if you didn't know this, they rank the brightness of stars on something called the star magnitude scale, and so this equation relates the diameter of the lens of your telescope to the limiting magnitude, so of the faintest star you can see. So obviously a bigger telescope lens will allow you to see stars that are further and further away. So you should be able to see a fainter star with a bigger telescope lens. And I know Mr. Kaplan will chime in if he has any relevant comments here.
Okay, well, I wasn't going to, but now that you mentioned it, if you're ever buying binoculars or a telescope, people think magnification is what they want. But if you want to look at stars and it's dark out, what you really want is a big lens because it gathers more light, and that's just what this says. So I have some binoculars that are good for bird watching, but at night, since they don't have a big wide lens, they don't capture enough light to see the faint stars.
Beautiful. All right, so the first thing you're going to do on these problems is decide. I'm going to give you an equation with 2 variables and then a number to plug in, and you're going to just make sure you read it carefully and plug the 11.1 in the correct place. 11.1 is the magnitude, L is the magnitude. So I'm plugging in 11.1 for L, and I'm trying to find D. It says find the diameter, so I'm finding D. All right, and when we're an equation that uses ln, we ask ourselves, is the ln of something by itself? Well, I want to ask the same question, but I want to ask, is the log of something by itself? And the answer is no, right? What do you think I need to cancel out first?
17.1.
Yeah, the 17.1. I mean, just imagine this log of d was just an x. We always save the coefficient of x for last when we're solving an equation. So yeah, we would subtract 17.1, and that's going to give me negative 6 equals 5.1 times the log of d. Hopefully this is an obvious question, but how are we going to get rid of the 5.1? By what?
By bringing back the 5 on the square root of d. Oh, by bringing 5.1 on top d.
Oh, so look, I think you're overthinking it, Truza. What if I had negative 6 equals 5x? How would I get rid of the 5?
I divide.
Yeah, so same thing. I'm not sure if that's what you were trying to say, but yeah, we just want to divide both sides by 5.1. And I'm going to guess negative 6 divided by 5.1 does not come out nice, so I'm not even going to bother checking. I'm going to leave it as a fraction. I don't want to round off anything until I have my final answer. Can somebody tell me how to rewrite this now?
we introduce log.
Well,
10
think
to the
back.
power.
What is it?
Never mind.
Say it again, please.
10 to the power of minus 6 over 5.
Thank you. Yes. If you think back to the first day we did logs, we did problems like this. Log base 2 of x equals 3. We'd say 2 to the 3 equals x. It's not written, but this is a log base 10. So we rewrite it the same way. 10 to the negative 6 over 5.1 equals d. You put this formula into your calculator. And if I remember, the final answer is 0.067 meters, if I'm not mistaken. Yeah, so 0.067 meters. Which is between 6 and 7 centimeters, right? Did I lose anybody on this one? Okay. Let's do a little practice quiz. I'm going to split you up into groups. There's quite a few people that have 4 points coming to them. Another set of people that have 2 points coming to them, and 1 or 2 people that haven't gotten any points left. So let's see if we can change that. And I think next time we do this, I will have pre-assigned breakout rooms, but I did not remember to do that today. So we're going to do some random breakout rooms again. Let me just email you the file. Let's spend some quality time on this. Let's go 25 minutes. Then we'll go over the answers, and we'll spend a little time talking about last night's homework, some of the trickier problems. All right, so and if the first problems are easy for you, then start with the tougher ones, challenge yourself. But it is a decent representation of what the quiz will look like tomorrow. Make sure I actually attach the file this time. All right, I'm sending that out to you now. Let's do some breakout rooms. Let's do 3 rooms this time, because I know some of you guys end up leaving soon. So do 3 rooms. Please make sure if you're in room 1, you utilize Mr. Kaplan's help, and I will stay in the main room and be there for anybody that wants to jump in and get some answer some one-on-one questions. All right. Jade, are you there? Hello, Jade. Jade, hello.
I have a question on number 2.
Yes.
Was that supposed to be e to the ln?
Let me take a look. Let me just open it up. Nope. Hold on. I'm going to share my screen with you in just a second.
Okay.
Okay. All right. Okay. This one right here?
Yeah.
So what happens? The ln just cancels out the e and you get what?
X to the second.
X to the second, right. There's no work you'd have to show on that one. That's just x to the second.
Okay.
Okay.
Thank you very much.
Pleasure, yeah. Jade, are you there? Jade, hello. Jade, hello, are you there? Hi, Victoria.
I got a question on 10.
Okay, let's see. Okay. Okay, yep. So,
So,
go ahead.
oh no, you.
Well, so the thing is, it's not base E, so you're going to have to take the log of both sides. So you're going to start off log of 3 to the 2x equals log of 0.26, and then you're going to move the 2x in front. Does that help, or should we keep going?
Yeah, I know.
Yeah,
Wait. Then would that be when I divide it by log of 3? Then would that be times 1/2?
yeah, sure. That's a nice way of looking at it. So you got 2x log of 3 equals log of 0.26. So now you have this 2x equals log of 0.26 divided by log of 3. And now you're just going to multiply by 1/2. Is that what you were thinking?
Yeah.
Perfect. That'll work. Yep.
So.
If you're doing it right, you should get about negative 0.613.
Yeah, I got that.
Good.
Thank you.
Pleasure. When we go over this, I'll show you a faster way we could have done this one too, okay?
Okay.
All right. Hi, Jakina. Are you there, Jakina?
Oh, sorry. So we have a quiz for tomorrow, right?
Yes.
Okay.
Okay.
Got it.
I had sent you a little practice quiz, and people are working on them in breakout rooms. Can I?
My internet just like shut down. That's why.
Yeah. We'll tell you what. We're gonna in about 10 minutes. We're gonna start talking about them. But why don't I send you to breakout room 3, so you can ask some questions in there, and compare notes with some of those kids. Does that sound all right?
Okay. Yes.
Okay. And how you doing, Victoria?
I'm good. Sorry for the question, but for 11, you posted something, but I really didn't look at it.
Yeah. So let's take a look at it together. All right. Okay.
There was a little note about the numbers, but I didn't really look at it because I was solving others.
Oh yeah. So the note was this 200 is supposed to be 2,000. They're all supposed to be 2,000. So what's different about this is you don't need any logarithms to solve it, because I'm not asking you how long it takes. I'm not asking you to find the t or the r. All right. So I'll start you off. I want to have $2,000. How much do I need to have now? My interest rate is 5%, and I need this money in 2 years. So think about that. See if you can get P by itself. You can do it in one step.
Okay, I was just sent here to check. That should say $2,000, right?
Yeah, I sent a little message, but those
okay,
only stay on the screen for a minute. Yeah.
Okay.
Do you think you know what to do from here?
Yeah.
Okay, yeah, just divide both sides and then you're good. And if you get an answer that's less than $2,000 but not too much less, then you did it right.
Okay.
And if you don't, let me know and I'll help you some more.
Oh. I got 1,809.
You got it. Yep.
67.
And 67 cents. Yep. Beautiful.
Thank you.
Pleasure. Jade, are you there?
Hey, Mister.
Hey.
So I'm kind of confused with number 10 because there's no in or
Yeah.
E?
Yeah, so let's take a look at it. Let me screen with you. Okay. All right, so number 10, right? So yeah, there's no E, so we have to use, we can't rewrite it using ln. We're going to have to take the log of both sides. So I'm just going to go ahead and say the log of 3 to the 2x equals the log of 0.26. And now this exponent comes in front. So now I've got 2x times the log of 3 equals the log of 0.26. Remember doing those last week?
Yeah.
All right. Do you think
Thank
you have
you.
it? Yeah, sure. No problem. Hmm. Hmm. All right. So welcome back, everybody. Let's start going over these. Let's see. Okay. All right. Let's start going over these, and please speak up if you have questions. I had sworn I put a log base 10 question on here. there's definitely one on the homework. Please make sure you try that and speak up if you have any questions on that first thing in the morning. All right, Diana, what did you get for number 1?
I got 3x.
Yeah, 3x. And there's no work you would have to show on a question like that. This just an answer. Give Elizabeth a minute to rejoin. Nicoletta, what did you get for number 2? X squared, good. Nothing more difficult than that. How about Alani? What did you get for number 3?
X to the power of -2.
Good. X to the -2. And if I had asked you to rewrite that without negative exponents, what would we do?
X to the power of 2.
Well, it would be, I guess that's, yeah. So to rewrite it, keeping it, yeah, if I said without negative exponents, you could just take the negative away. But that is the same as 1 over x squared. All right, but nice job. All right, Mata, what did you get for number 4? This was the trickiest one out of the first 4.
I'm looking at my answer now. I'm doubting it. So it would be x to the 30th.
Okay, so let's take a look at this. Let's take into pieces. We're going to put the 3 up here as an exponent. We're going to put the 5 up here as an exponent. There's more than one way to do this, but let's start with that. So if I had e to the ln of x to the 3rd plus the natural log of x to the 5th, I've got a log plus a log. I can make those into one log by multiplying. What's x to the 3rd times x to the 5th?
15.
Nope. Yeah, don't forget x to the 3rd to the 5th is x to the 15, but x to the 3rd times x to the 5th, we're just adding exponents. X to the 8th, and the final answer is just x to the 8th. Another thing we could have done, somebody might have recognized these are like terms. 3 natural log of x plus 5 natural log of x is 8 natural log of x. And now we can move the 8 onto the x as an exponent, and we'll get x to the 8th either way of doing it. Does that make sense, Mata?
Yep.
All right. Good deal. Okay, let's move on. Jocelyn, how about Josie, number 6? What'd you get for a formula, first of all?
For a formula,
Yep.
I got x equal ln 10 over 3.
10 over 3, okay. And what'd you get for a final answer?
1.2039.
Good. 1.204 or 1.203. And the 10 over 3, she just reduced the top and the bottom. Took 2/3 of the top, 2/3 of the bottom. And just for what it's worth, teachers that do want to see reduced fractions, usually if it's an intermediate step, nobody cares. So you could have felt free to kept this as 15 over 4.5, but nice job nonetheless, either way. All right, how about On? What did you get for a formula for number 7?
I got e to the 28th power over 2.
Good.
And the answer is 7.231 times 10 to the 11th.
Good. 7.231 times 10 to the 11th. And those of you that have a Texas Instruments calculator, you're going to see 7.231 E11. And one of the questions tomorrow, it's about an earthquake. How many joules of energy are released by an earthquake? You're going to see this E, and make sure you understand that's the Texas Instrument Calculator way to write scientific notation. But this is not something that's acceptable on your paper. You have to translate that into scientific notation. All right, and I think the instructions say use 4 significant digits. So that's 1 before the decimal and 3 after the decimal. All right, and if you don't have a TI calculator, maybe take a minute and put this in your calculator and see what it does look like when you have scientific notation, so you recognize it. But don't ignore that capital E if you see it. Would anybody like me to wait for a minute before I move on so that we have time for people to check? All right. All right, let's move on then. Number 8, Ramon, what did you get for a formula for number 8?
I got natural log of 15 plus 3 equals x.
Good. Natural log of 15. And the brackets aren't necessary if there's a clear space between
them. And then I got x
Yeah.
equals 5.708.
Good. 5.708. Nice. All right. Elizabeth, what did you get for number 9 for a formula?
For 9,
Yeah.
I got x equals e to the power of 5 minus 1 over 3.
Good. And what'd you get as a decimal answer?
49.138.
Good. 49.138 or 0.137 would have been fine. All right. Let's see. All right, Brian. Oh, first of all, would anybody like to go over 6, 7, 8, or 9 in more detail?
Could we go over to 7?
Sure, yep. All right, so the first thing we want to do in number 7, we want to get the natural log of something by itself. So this 3 has to go. So I've got natural log of 2x equals 28. And now once you've done that, now natural log of something's by itself. Now you're ready to rewrite e to the 28 equals 2x. The log equals 28, so the 28 is the exponent. And now all I have to do is just divide both sides by 2. Does that look okay?
Yep.
Would you like me to show you what it looks like on the TI calculator?
No, I'm good.
Okay.
I think I just ordered it wrong.
Okay. All right. Yeah. So as long as we understand, I mean, that's pays to speak up, right? You figure out what you did wrong, and then you won't do it again tomorrow. Anything else on 6 through 9 before we move on? All right. Then let me move on to Brian. What'd you get for a formula on this one, Brian?
I got log 0.26 over log 3 divided by 2.
Okay. Okay, and you can do this whole thing, yep, divided by 2. We could have also, somebody else might have written it like this. What did you get for your decimal answer?
I got negative
0.6, you said?
Yeah.
Yeah, 6, and make sure you give me 3 places tomorrow. But yep, nice job. And
I have a question.
Yeah.
Can you multiply it by natural log?
Yeah, that's a great point, Ramon. In fact, I meant to mention that when we did this before. Thank you. You could have easily, you can take any kind of log of both sides. So you could have had ln of 0.26 divided by to ln of 3. That's a great point. You can take the natural log of both sides or the common log of both sides, and you're going to get this same answer.
Okay, thank you.
Yeah, here's something else too. Just what you could have done if you had looked at this as 9 to the x equals 0.26, you could have done the log of 0.26 divided by the log of 9, or ln of 0.26 divided by ln of 9. That would have made your work go a little bit quicker. Okay. So let's see here. I haven't called on Mark yet. Mark, this was a little bit different because we're not solving for the exponent. What did you get for your formula on this one?
I got 1,000. Oh, formula?
Yeah.
2,000 equals P times E to the 0.5 times 2.
Yes, okay.
Formula.
Yeah, so good. So that's all right. So that's our setup. We're trying to find P, and how do we solve that? How do we get P by itself?
2,000 divided by E to the 0.1.
Yeah, so Mark multiplied this in his head. 0.05 times 2 is e to the 0.10. And what'd you get for a final answer?
1,809.68.
Good. I think it was 67 cents, but you get the right idea. So, yeah, and that's a word. Sometimes you'll hear the present value of the $2,000. Sometimes if a team, a sports team signs an athlete to like a multi-year deal, they need to know what's the present value of that deal. How much do they have to have in the bank now to be able to pay that salary, in the second year and the third year and the fourth year. They don't have to have all of it now if they're guaranteed of being able to make a certain interest rate. All right, so, but tomorrow you expect to be finding T on this one, which we've done a number of times. All right, now let's go on to the tough one here. Okay. Victoria, what's the initial deer population here?
I got 11.
Yes, nice job, 11. It's really 1,001 divided by 1 plus 90. So 11 deer. Okay, and all right, let's give group 1 a chance to come back here. Trues, are you still here or no?
He had to go.
No, he had to leave.
Okay. So Diana, we'll go back to you. What did you get for your formula on part B?
I said ln 401 divided by 54,000.
Nice.
Divided by negative 0.2.
Good. And how many years did that end up being?
24.514.
Good. 24.514 years. All right. So we've got 3 groups, all with 4 correct answers. Why don't we have people put in the chat real quick your answer to part C, and whichever group gives me the most correct answers on this one. Yeah, by the way, Mark, I got 67.4 cents, so that would stay 67, but All right, I'm giving a
No,
minute.
I think there was a 5 after that. I'm pretty sure.
So my calculator, I got a 4. Let me just double check that. 2,000 divided by e to the 0.1. I'm getting 1809.674. Like, all right.
Yeah, but there's an 8 after the 4, so that makes it a 5, and then once you round the 7 up.
No, so you're gonna pick. Oh, I'm glad this came up. You're gonna pick. If you're going to 2 decimal places, you look at the third number. So the third one's a 4. So to 2 places, it's 67. If you're going to round to 3 places, now you look at that fourth number. The 8 would make it 0.675.
Mm-hmm.
Okay.
So I wouldn't look like I have.
Right. So yeah, just be careful that you don't double round. You don't round to the third and then to the second. You pick, I'm either rounding to 2 decimal places or 3 decimal places.
Mm-hmm.
Okay.
Thank you.
Yeah. All right. All right. Let's see. So let's do it this way. I got. Diana. Okay, everybody. It's kind of funny because everybody can see each other's answers. All right, so tell you what. I got the most answers from group 1 here, so we'll give group 1 the points here today. But let me go back to this for a minute. In theory, there's a better answer than 1,001. You guys were paying attention if you said 1,001, but in theory, right? If this equation is 100% accurate, this 1,001 represents a horizontal asymptote. We can never quite hit 1,001. We can hit 1,000.999 deer, but in theory, the biggest number of deer that could possibly live in the park would be 1,000. If somebody asks you what's the carrying capacity, we'll say 1,001, and it rounds off to 1,001 deer. But if this equation is 100% legit, this can never quite equal 0. So consequently, this can never quite equal 1,001. So if somebody told me 1,000, I would have given that group the points. But I had the most answers from group number 1 in the chat, so we'll take that one. All right. So any last minute questions on this? If so, we'll take them. If not, we'll spend a little bit of time talking about last night's homework and some of the more challenging problems. All right. I won't go too long because I ran us kind of long yesterday. But any last minute questions? All right, there's no piecewise defined functions on tonight's homework. We'll probably spend most of tomorrow's class on piecewise defined functions. And then I got some pretty cool problems for next week that are modified AP problems. Give you a little taste for some open response AP questions where we can solve them without calculus. So what do I want to do here? The homework. Let's move on. I wish I could remember who it was, but one person came really, really close to answering everything on here correctly. Okay. Yeah, you know what? I think this just might be a very big file because of the resolution. So a couple people just didn't understand the word discontinuous. So discontinuous, basically the intuitive version of this is that if I'm following the graph with my pencil and I have to pick up my pencil to continue following the graph, like right here, I have to jump up to this part, it's discontinuous at x equals 1, t equals 1. And then I follow it up here, and then to continue following the graph, I have to jump down here. So there are 2 places where this function is discontinuous, and those are at t equals 1 and t equals 3. All right. Domain and range. Ramon was asking if we were going to get into domain and range yesterday, and he must have been psychic. Domain is the set of x values. Range is the set of y values. The furthest to the left this graph goes is -7. The furthest to the right it goes is +9. And we've covered every x value in between. And by the way, what is h of 1? This open circle, closed circle. Which one is the actual y value? The closed circle or the open circle?
The open. Oh no, I mean the closed circle.
The closed circle. So h of 1 is this 2/3, not the 2. And h of 3 is 5, not 4. H of 3, we're looking at this piece of graph here. But once we get to 3.1, now I'm looking at this piece of graph. Is all x values between -7 and +9. And the lowest y value we have is -2, and the highest is 6. And we've covered every y value in between. So we can write that like this. Y, or h of t, is always between -2 and +6. The absolute, there's some terminology here. Absolute maximum is the very highest y value on the graph. And the coordinates of the point where we have an absolute maximum are 5, 6.
I have a question.
Yeah.
Wouldn't it be 6 on the front of the range and then -2 on the most?
Well, you can write it like this also. You can write the 6 first, but if you do, now your inequalities have to point to the right.
Okay.
Okay. If you're using interval notation, you always have to put the smallest number first. But these kind of compound inequalities, you can lead with the highest number, but both of these inequalities have to point to the smallest number. And if somebody asks you what's the absolute maximum value, you just say 6. But this is of the point where we have an absolute maximum. The absolute minimum value is a y value. It's -2. All right. H of t is increasing. All right. This is an important concept in calculus. Where's the function increasing? Everywhere where the slope is positive, everywhere where the graph is going up from left to right, first of all, it's decreasing. Then it's increasing. Then increasing. Then decreasing. So there's 2 places where we're increasing, from 1 to 3, and then from 3 to 5. So I'm increasing on the interval. I'm going to say on so people know this is an interval, not a set of coordinates. Then I'd say at. On the interval 2 to 5, and on the interval, 2 to 3. What am I doing? 1 to 3. From t equals 1 to t equals 3, we're increasing. And from 3 to 5. And I'm decreasing, this first line segment I'm decreasing. So I'm decreasing on the interval -7 to +1. And then once I hit the peak of this piece of a parabola, I'm decreasing again. That starts at t equals 5 and goes to t equals 9. But
wouldn't you have like a bracket instead of a parenthesis for the 3?
Yeah, it's a it's an important question mark, but think about it. At 3, right? At 3, the points to the left of me are lower than me, and the points to the right are lower than me, right? If I'm increasing, I want the point to the left of me to be lower and the point to the right of me to be higher. Are you following me on that?
It can't be 3.
Right. And I'm not really saying t equals 1 because I'm decreasing before t equals 1, but then right after it I'm increasing. So at 1 I'm kind of like in transition. Does that make sense?
Oh, okay.
All right.
Yeah, that makes sense. Thank you.
All right. And then, questions B and C were about transformations. Question B is 2 spaces left. Well, then the maximum point occurs at 3, 6. And if I was to shift the graph 2 spaces up, well, then my lowest value isn't -2 anymore. It's 2 higher than that. It's 0. See how we're doing on time. Okay. Let's get into the next page a little bit, and I'll next 5 minutes. So these questions here about the equations for the graph and translating the graph to get a continuous function. Let me just go back to this. How about, let's start off with this. The portion of graph on the interval 3, 9 is parabolic. What's the equation for this portion of the function? Whoops, I pressed it at too high a resolution, and it didn't do me any good. I had some knowledge of the right kind of math on this, but I just wanted to point something out to you. So this is my vertex of this piece of parabola. So I know it has this format, some negative number. My vertex is 5, 6. So I can write this in the format some negative number times x minus 5, and I should be using t and h of t, plus 6. And 1 or 2 people just put a -1 in front because they know it points down. But we actually had enough information to get more specific. I could use this point or this point, 9, -2. I'm going to plug in the point 7, 4 to get the value of a. 4 is my y value. 7 is my x value, plus 6. I'm going to subtract 2 from both sides. 7 minus 5 is 2. I think slowing down. 4a. I'm going to divide both sides by 4, and I'm going to get -2/4 or -1/2. So to describe this portion of the graph, we can use -1/2 t minus 5 squared plus 6. Okay, and I saw one person, there was a question that asked, when is h of t less than 0? Well, first thing we want to do is look at the graph. The only portion of the graph that's where we have negative y values is this portion right here. And so to solve that, when is the function negative? I'm going to need to use quadratic formula and this equation right here. So let's do this real fast. If I expand this out, -1/2, and if hopefully a lot of you guys can do this in your head, t minus 5 squared is going to give me t squared minus 10t plus 25. All right. And so first of all, I want to see when is it equal 0, because I know after that it's less than 0. So I'm going to distribute this -1/2, -1/2 t squared plus 5t minus 25 halves plus 12 halves on the 6, right? So -1/2 t squared plus 5t minus 13 halves equals 0. And if we're going to use quadratic formula, I don't want fractions. I'm going to multiply the whole equation by -2. So I'm going to get t squared minus 10t plus 13 equals 0. And now I can use quadratic formula. Positive 10 plus or minus the square root of 10 squared minus 4 times 13, which would be 52. I wrote 100 squared. because I was saying 10 squared, and all over 2. So that's 10 plus or minus the square root of 48 divided by 2, and then depending on what we're using this for or who our teacher is, we might want to reduce that to 4 root 3, and pencil on it, 5 plus or minus 2 root 3. And this one is obviously the 5 plus 2 root 3, because 5 minus 2 root 3 would be, this one over here. Where it, so anyways, the answer to where is the function less than 0, it would be on the interval after 5 plus 2 root 3 up until positive 9. And I would include positive 9 in that interval. All right, and something that I just want to point out. Now, this one, when you write the rules, if you look at my answer key, it is important which one includes 3 and 3, because now they're not the same. So you do have to make a distinction between square brackets and rounded brackets in your interval notation when you're writing the rules. I said I was going to go 5 minutes. I went 8. So let's call it a day today. Nice job, guys. Try to be on time tomorrow because the test is from 8 to 9, and we'll just start it right away. And if you want to stick around, I'm not going anyplace, but other morning.
Have a good day.
You too. Thanks.
Bye.
Bye-bye.